Hello, in this lecture we're going to discuss soil organic matter. Previously I've said that soil organic matter is pretty much the solution to just about any soil problem, and that remains true. So today we're going to talk about soil organic matter and that it's the foundation of our productive ecosystems. Um, And so let's move on. Our learning objectives are to discuss the critical importance of organic matter and soil health, identify biological and physical mechanisms of addition or loss, predict how management changes impact of long-term carbon storage. So let's talk about that. So you can see here that in this little diagram, it's a bit of a cycle how this works. And um, things go into the soil and things come out of the soil, right? What things go into the soil? Well, plants absorb, I'm sorry, what goes into the plant versus what goes into um, the air is important as well. So a lot of that gas exchange that occurs inside of leaves is really important because plants absorb CO2 through photosynthesis, and photosynthesis creates the energy that runs all of the plant functions. It also means that the proteins that the plant needs and fats as well are all part of this process that goes throughout the plant. Soil nitrogen is collected in in the soil up into the plant roots and then is taken up and created into the amino acids that are needed to create the plant. Um, so how does that happen? Well, that happens through decomposition of dead and dying materials, and then through associations with microbiology, they are then taken up, and the nitrogen is then changed and then made in a plant available form and then taken up into the plant for use throughout the plant. And so what we get is kind of what we call a carbon pump. Plants convert the atmospheric CO2 into organic forms, removing it from the air and storing it in the plant. And then as the plant dies, and then it actually gets stored in the soil as an organic form or an organic form, and then can be uh, transformed by microbes into other materials. Now, plants, as they die and decay, they do release that CO2 back into the atmosphere, but some of that is stored. And so we call soil a carbon store or a soil bank for carbon because it stores some of that carbon in the soil, making it unavailable for the atmosphere, and helps keep our CO2 levels at a more moderate level. So in soil, we've got two major types of soil organic matter. We've got soil organic matter that we just call that SOM, and that is a broad term referring to any material consisting of organic carbon, anything that once was alive, includes fresh residuals and active microbes as well. So fresh residues, sorry. Humus is something we've already talked about, but it is also a stable, well decomposed fraction of organic matter. It persists in soils for hundreds of years and provides the characteristic dark color. In most cases, what you're going to see is a dark color in the soil as a result of um, soil organic matter. And then all of those impact the soil properties that we've previously discussed. Soil structure, the glue, it's the glue that creates aggregates and improves aeration and root penetration. So organic matter, really important in that area. Soil water holding capacity, so it's available that helps hold on to the water that we need and want in our soils so that plants can grow. So really important there. Compaction, it improves soil resistance, helping the structure resist heavy equipment or foot traffic damage. So it helps resist that compaction that allows for the soil structure to have aeration, stuff like that, allows roots to penetrate down deeper into the soil to mine those minerals and nutrients that are available. So let's talk for a minute about chemical and biological benefits. I've talked previously about the cation exchange capacity, and we're going to go deep into the cation exchange capacity next week. But for now, just remember that the CEC, the cation exchange capacity, is an important mechanism to get nutrients into the roots. And it does have to do with ions. And so we're going to talk more about that later on. But organic matter is the primary driver of the cation exchange capacity. And it is the reserve or reservoir of nutrients in plants as a result of that function. You can always look again for the dark color. That's the visual indicator for soil organic matter. And of course, if there's dead and dying materials, that's the food for many microorganisms and makes it possible for them to grow and to develop. At the same time, they metabolize that soil organic matter in a way that is also helpful to future plants, especially when it comes to soil nitrogen and other nutrients. So in order to understand that, though, we need to understand the mechanisms behind decomposition. Okay, so additions and losses to soil carbon. Okay, and so remember, soil carbon, we said it a few minutes ago, soil carbon is really what we're talking about when we're talking about soil organic matter. We look at all of this dead material that is in the soil, and what we should automatically see when we see this stuff is carbon. This is all carbon, different forms of sugar for the most part, okay, in different, lots of cellulose, and all those carbons are bound together by chemical bonds that when broken release energy, and that energy needs to be utilized by different life forms, microbes, and then future plants as a result, okay? So it is definitely our food source. And when we're looking at our food source, we're looking at the carbon to nitrogen ratio. Okay, so carbon is C, nitrogen is N. And so that ratio is important. Now, in high carbon to nitrogen ratios, say in wood, so it's mostly carbon and very little nitrogen, that means that you're going to decay very slowly as a piece of wood. As you know, it can last quite a long time, especially here in the arid Southwest. Wood can last longer than we will because it doesn't decay very quickly. The other environmental drivers is oxygen, right? So oxygen, the presence of oxygen helps provide the oxygen needed for microbes. Many of the microbes are aerobic and require oxygen in order to function. On the flip side of that, there are some anaerobic or microbes that don't like oxygen that can function as well. But most of the ones that we are going to be worried about are the aerobic. It says here the anaerobic or saturated conditions slow microbes. So what's this anaerobic is doing is it's slowing the amount of oxygen to be present, and therefore you don't have the microbes present that are needed to decompose much of the dead and dying organic matter, okay? And obviously temperature is also really important, right? So in many chemical reactions where life is involved, they need heat. And if it gets too cold or even too hot, it slows down microbiotic activity and it doesn't allow it to take place. Whereas nice warm temperatures, moderately warm temperatures are ideal for microbial activity in soils, and so that is a big driver in decay. I think the only thing I'd add to this, these three are really water. So the presence of water. So obviously water is in more abundance in other parts of the country and less here in the arid Southwest. It gets plenty warm and we can get plenty of oxygen, but without water being present, there is a lack of microbial activity. And so I would say that that's another important driver that I should have a box here for. So let's look at a case study. So we have a bit of a paradox. Thick layers of leaf litter. So litter is just what we call the dead material sitting on top of like the forest floor or the any rangeland or anything like that. So litter, that's what we're calling that dead material. So thick leaf litter suggests high soil organic matter, but much is undecomposed due to periodic saturation. So in some cases, if you've got a thick leaf layer here and it's rained a lot, that water will be held in this leaf litter, preventing oxygen to getting into the soil, and therefore lack of oxygen, you're not going to get quite the amount of decomposition as you might otherwise get. We want to talk about this phrase here, the active pool. So this is the pool of active nutrients that are actually going through the decomposition and actively making organic matter available to other organisms. So high precipitations and waterlogged conditions limit the transition of litter to active organic matter that have nutrients that can be reabsorbed and used by microorganisms. So we can do a bit of a calculation here to tell you how much of an acre is available for use by other plants. And so we're going to learn a phrase here, acre, furrow, slice. And so what you want to think of with an acre is a square piece of land, right? And that square piece of land, soil has a depth to it, so it's a three-dimensional object. So think about it going down about 2 3/4 inches, and that 6 3/4 inches. That area of soil depth is pretty much where most of the organic matter is going to lie. For all intents and purposes, you're not going to find organic matter below that level for the most part. Of course, there are always exceptions to the rule. And on average, that soil is going to weigh about 2 million pounds. So how much of that 2 million pounds is organic matter? Well, we've got a benchmark here, 5%, as you know, we've talked about it on average, is out of the total soil structure is organic matter. You remember that 25% was pore space and 25% was water, and the other 5% was organic matter, and the other uh, 25% was organic or mineral soil. Okay. All right. So let's ask the question, um, how much of that is soil organic matter? Well, 2000 times 0.05 um, is, or 5%, is about 100,000 pounds of soil organic matter out of 2 million. Now ask yourself the question, how much of that 100,000 pounds of organic matter is usable nutrients that can, or is active, an active soil organic matter actively involved in um, uh, um, mineralization, or sorry, lost my train of thought, or is actually being can be used for life. I lost my word. So we're going to look at nitrogen, and you remember that nitrogen, besides water, is the most limiting nutrient out there for plants. And as a result, we can calculate roughly how much nitrogen is available. And so we've got 100,000, and it turns out that about 5% of that total nitrogen is, of that soil organic matter, is nitrogen. So we've calculated about 5,000 pounds on average. So we went from 2 million pounds of soil down to 5,000 pounds of total nitrogen. And we could very easily calculate that about 3% of that nitrogen is going to be released every year. Okay. Now here in the arid Southwest, it's probably much less than that because we don't have the water present. So let's just say on average it's about 3%. So 3% times 5,000 gives us 150 pounds of available or active nitrogen, biologically available nutrient for the plant. Okay, that's it. That's all that they have available. And if they use that up, and they do, then they've got to find it in other places. Now, there are some other naturally occurring places for nitrogen around. You can get a little bit of nitrogen out of lightning, for example. And of course, there's runoff. So soil nutrients can be moved from place to place. Um, Sometimes when it's excessive amounts, it actually can cause algae blooms. And so that can happen as well. All right, so to end our little presentation here today, we're just want to make sure a few things are clear. First of all, soil is a critical global carbon storehouse. That's where we store a lot of our carbon, is in the soil, because of all of these cycles that take place. And it's actually pretty important to us. We don't want too much carbon in the atmosphere. As you know, that when there's too much carbon in the atmosphere, it causes a greenhouse effect and warms our planet. So we'd like it to be in the soil. Soil organic matter drives the structure of soil and water and nutrient capacity. And so as we think about what it is we're doing with um, the land that we grow on, we also need to anticipate what effect our actions, our management actions, will have on the ecosystem, right? So if we cover the ground with pavement, then that soil is no longer available for the nutrient cycle, or the carbon cycle. And so we got to consider that too. We also have to consider that when, if we do controlled burns, because that means we're releasing some of that back into the atmosphere. And so those are all things that we need to consider. Obviously, fires are a natural component of our ecosystem, but it's still something to consider. Um, so anyway, I hope if you have questions that you'll send them my way, and I hope you have a great day. Thanks. Bye.